This video will explain how we develop the surface area formulas for prisms and pyramids. To start with the prism, I'm going to start with its base. And for this base, I'm going to create a regular polygon. I'm going to make a regular pentagon, as we can see here. Then I can use the extrude tool, which will turn it into a prism. It just layers it on top of itself. I decided to make my prism have a height of 6. So as we can see, we have a pentagonal prism. And if we look, our bases, the sides on the top and the bottom, those bases are going to be, pentagons, and then each of these faces on the side, what we call our lateral faces, those are going to be rectangles. So what we can do is we can actually derive the formula for surface area. Obviously, we're going to have to calculate the area. We're going to have to calculate the area of the two bases, and that's going to be 2b. But then we need to calculate area of the total lateral faces. The total lateral faces, though, are just going to make one giant rectangle. That rectangle, well, for rectangle, we need the length, or the base, and the height. The height is going to equal the height of the prism. But the base, if we look at our figure, the base of this rectangle is this side of my pentagon. The base of this rectangle is this side of the pentagon, and so on. So the base is actually the perimeter of the base. So I can calculate my rectangle as P times H. So that gives us our total surface area. And this right here is our lateral surface area, because it's the area of the lateral faces. So now we have our lateral surface area, and we know our area of the bases. So to find our total area, we will just have to add up the lateral area, which is perimeter times height, plus the two bases. So that's how we develop the formula for surface area of a prism. Now we're going to look at the surface area for a pyramid, which is our new topic for today. So what I've created here is I have a regular hexagon. We can see it's got 6 vertices, 6 sides, and I'm going to use the extrude tool to turn it into a pyramid with a height of 4. So if we rotate this around, we see our hexagonal pyramid. So for our hexagonal pyramid, we know that the shape of the base is a hexagon. So we know the shape of the base is a hexagon. We can also look at the lateral faces. These are our faces that connect the base to the top vertex. And we notice that the lateral faces are triangles. We know that the area of the base is going to be capital B, just like for our prisms. But now we need to look, what is going to be the area of the triangles? So we know that the formula is going to be 1/2 base times height. The question is, what is the base? Well, if we look at the base individually, the base of this triangle is this segment right here. Then I've got this segment over here for this base. And if we keep going around, you notice that all of the bases are actually, they are going to be the perimeter of the hexagon. Now we also need the height of the triangles. Now this is the tricky part because the height, so the tricky part about the height is that the height is not the height of our actual pyramid. If we look at our pyramid, my height is 4 units. But we actually need this measurement. And if I rotate that around, you can see that that measurement is a diagonal piece. We're going to call that segment. We're going to call that segment the slant height. And we represent slant height with a lowercase l. When you're writing your slant height, you want to write it in cursive so that you can tell the difference between the slant height and like a number 1. So we now know that the height of the bases is our slant height. So our formula is going to be 1/2 PL. So our total surface area for a pyramid will be 1 base, because there's only 1 base on a pyramid, plus 1/2 the perimeter times the slant height. And we notice that this portion right here, the 1/2 perimeter times the slant height, that is our lateral surface area.